Okay, good morning all esteemed judges and all audiences. First of all, happy Sunday to all of us. I'm not going to say happy holiday because it's not quite a holiday for me. So many jobs to be done. But, okay, straight to the point, I'm going to start with the same quote as the last one. Res pice, as pice, pros pice. The past, the present, and the future. I would like to share some of my experiences. When I was a little kid, I have no interest in energy. I don't know what energy is. I just simply turn on the PlayStation, the computer, and I play all day, without knowing that the PlayStation runs on electricity. Everything runs on electricity that you used to play, you used to be playing with. And of course, now as we can observe, there are so many demonstrations. Kami menolak harga kenaikan BBM. We are against the increase of the BBM price, the gasoline price, and also the tarif dasar listrik, the electricity price. They are always against the increasement of the price. And now that gasoline and gas is not enough again to supply the demand of our energy, we need another alternative energy sources. This is the future of our energy demand. And so, ladies and gentlemen, allow me to present the integrated thermoelectric generator on behalf of myself and Alden Westputo, my partner from the SMA Polisi Dionisius Jakarta. Research backgrounds. First one is the need for newly alternate energy resources. We cannot rely on gas, on oil anymore. It's not suitable for us. And the second one is an alternative technology to be applied on solar energy harvesting instead of the solar cell one, the conservative one. Last but not least, global energy crisis, as I have said before. These three backgrounds have driven me to a love in energy, because I also come from a homogeneous school like Mrs. Reed. So it is better for me to fall in love with energy rather than to fall in love with other boys. Research objective. This research was conducted in order to provide an efficient and effective way to utilize solar energy. Problem formulation. First of all, how to design a TEG system. The system in order to optimize the solar energy utilization. The next one is, does the use of solar energy as the ultimate source of TEG energy can satisfy our demand of energy. The research purpose is similar to the research objective, to provide an effective and efficient way in utilizing solar energy by utilizing its heat dissipation. Theoretically, this is a small diagram of how the thermoelectric generator works. And thermoelectric effect comprises from three different effects: Peltier, Seebeck, and Thomson. Peltier Seebeck effect happens when two different metal plates are given temperature difference. And the TEG utilizes semiconductor metal in order to optimize Seebeck impact. There are two types of metal semiconductors, type N and type P. This is the advantage of TEG generators application due to Indonesia's geographical location. We are located along the equator, which has constant solar radiation throughout the year. Unlike the Europe or the South Africa or Australia, they have a slightly longer daytime on the summer. Also, the TEG has also been considered to be applied on vehicles. The US Department of Energy and Boeing has considered to be using TEG on their vehicles. Why thermoelectric? There are so many sources. Why should we choose thermoelectric? First of all, long-term of life usage. Second of all, high reliability. The last one is simple maintenance procedure. And also, nothing is perfect. It also comes with weakness, which is low efficiency. It is very rare to reach more than 10%. In most cases, it's between 3 up to 7%. This is the basic principles of the thermoelectric generator. First of all, the applied heat absorber absorbs as much heat as possible from the solar radiation, and then the heat will be used to heat up the metal plate here, and the heat sink will be maintained cool by the air. There will be temperature difference between the metal plate and the heat sink. thus there will be a small amount of electricity. This is the testing. This is the previous one. You can see made out of cardboard without insulation system at the first time, and only aluminum foil as a reflector system. This is the new one. Stainless steel reflector, rotatable dock, and also tripod. This one, if Apple has got iPhone 1, and then this might be the iPhone 1. This, I proudly say as an iPhone 5 or maybe iPhone 6, I don't know. I'm very satisfied on this one, because actually it was, like I said just the night before, it was love at the first sight. When I saw this TEG, I just fall in love. Doesn't know about it. This is the pre-revised one, the cardboard one, the results. The maximum one is recorded on 0.013 watt. This is the highest output ever recorded on the previous design. Do note that the number 9 and 10 data, this one both 5 pieces of TEG, but still lower output because it was recorded on a relatively cloudy day. This is a graph of one TEG with 4 mm copper plate without insulation. You can see the highest one is 8.39 milliwatt, recorded on 12:40 until 13:38 Jakarta local time. And this is the same system with insulation. The highest one is 12.38 milliwatt, recorded on approximately same time, 13:40 until 14:48 local time. The insulated system produces higher power output. That's why we use insulation nowadays. This is the revised one, the stainless steel one. The highest output is 0.1 watt, about 10 times larger than the previous design. The solar efficiency. This generator should be able to generate about 3.78 watt at the theoretically. If you count it based on the metal plate area, this one, small area around here, the generated output power should be around 3.78, as I said before. But if you count it based on the reflector area, all the square around here, it should be around 30 watt. And here comes the solar efficiency. You can see the average efficiency of EM on the metal plate area is around 0.1253%. As I said before, it is very low. If we count it from the reflector area, it is around 0.016%. Data analysis. On the first test, the battery experienced increasement in current, but yet the voltage was decreasing. And we think about it, we think it's quite normal due to the battery discharging procedure. And then on the second test, same result as the first test. Then we must think further. And later we realized that there was some multimeter faulty. On the third test, we are using a new multimeter, yet the battery is still unchargeable. Why? Because the TEG system has a lower voltage compared to the battery. The battery has a higher voltage. Thus, the current flows from battery to TEG. I call it as a reverse current flow. This is the fourth one. We have learned from our problems. We try to make it better. We try to improve the system. There are 4 extra TEGs in order to generate a higher electricity. We also applied 2 mm aluminum instead of the 4 mm copper one. And also applied application of an insulation system. By the end of this procedure, it was easier to achieve 200 millivolt. This is the post-revised one. Post-revised one is even better. New high score, 0.1 watt. The record was recorded on the magnitude of 0.1 watt, and 166 milliwatt is easily achieved even on a cloudy day. Now, thus I could conclude that this integrated thermoelectric generator has a brighter future compared to the previous one. We can do further research on this one instead of the previous one. Future goals. As I said before, the first one is improve data gathering. Second of all, we want to try the reverse from flowing contraflow by applying a diode on the system. The third one, we are planning on a whole day test because we want to know the real performance of this generator in the field. So we want to place it on a whole day outside of the room, outside of our monitoring procedures. And then the last one, we are going to connect this system to a motor, to a small motor, a cellular form motor, in order to calculate the energy generated. In conclusion, the maximum power, output power, 0.1 watt generated from this one, the new one. The output is unstable due to the weather. The optimal time is about 11 o'clock until 14 o'clock Jakarta local time. And the hot side and the cold side, the temperature difference is proportional to the generated current. The advantage in using such items in tropical location is the constant length of solar radiation. This is the bibliography. I would like to thank all of them. And last but not least, I want to conclude. This is a small quote from Thomas Alva Edison. I put my money on solar energy. So, what a source of energy. So, why don't we look forward to use the solar energy instead of relying on fossil fuel, on gasoline? We should try considering the solar power. Personally, I'm also a cheapskate. Why don't we save on something that we can save rather than wasting fuels? We can try to use the alternative energy source as a solar one. Thank you. That's all for today. I believe that I'm the last one to present here. So you can enjoy your lunch. I wish you pleasant lunch.